Welcome to Scalecraft. In our last videos, we learned that a load balancer chooses the best server. But today, I have a trick question. Which particular load balancer? Imagine Amazon has data centers in Mumbai, Singapore, Frankfurt, Virginia. Before choosing the best server, someone first has to choose the right region. And that's where most engineers get confused. Because there are actually two different load balancers working together. One chooses the region and the other chooses the server. And by the end of this video, you will never confuse between these two load balancers. So make sure you subscribe the channel for more such videos. So let's follow Rahul's request. Rahul's live in Delhi, right? He opens Amazon.com. The request leaves his laptop. Now, here's the first question. Should Rahul request go to Singapore, Mumbai, or London, or which particular region? Who decides this? Certainly not the application server sitting in the Delhi. This decision happens much earlier, and that's where enter the global load balancer. Think of global load balancer as an airport control tower. Now, before a plane lands, the tower decides which airport it should land to, which region should handle this request, not which server. We are talking about which region. So for Rahul, the answer is probably Mumbai. For someone in London, it might be Frankfurt. For someone in California, it might be Oregon. So once the region is selected, another load balancer takes over and we call it a handoff. So there comes the regional load balancer. So in our story, we are reaching the Mumbai region. So inside this Mumbai region, Amazon does not just have one server. It may have hundreds or maybe thousands. Now, another decision has to be made. Which server out of these thousands should handle Rahul's request? Now, this is where the regional load balancer comes in. It prefers everything we discussed in previous videos. So it uses round robin, least connection, or any of those load balancing algorithms. It does not care where Rahul request came from. It only cares about distributing the traffic inside its own region. So remember this. Global load balancer chooses the region, whereas the regional load balancer chooses the server. And that's the easiest way to remember the difference. Now, there are two ways to build a global load balancer. So, which is very interesting. This is just one way to build a global load balancer. So, we are going to talk about two approaches. First is DNS-based global load balancer. Suppose Rahul types Amazon.com. The first thing his laptop asks is DNS. So, what is the IP address of this particular Amazon.com? A smart DNS service like AWS Route S3 does not always return the same IP. Instead, it looks at Rahul's location. Since Rahul is in India, it returns the Mumbai region IP address. Someone in Europe receives the Frankfurt's IP and similarly for another locations. Pretty smart, right? But there is one problem with this approach, the TTL problem, which we call time to live. Remember, DNS responses are cached. Suppose the DNS response says use Mumbai. The answers may be cached for 30 seconds, 60 seconds, sometimes several minutes. But during this time span, what if Mumbai suddenly crashes? Rahul's laptop keep using the old IP because it is being cached. So until the DNS cache expires, it will send the request to the wrong region. This is called the TTL problem, and it's simple, reliable, but not very perfect. Then we have another approach called Anycast routing. Can we avoid waiting for DNS cache expiry? Yes. This is exactly why companies like Cloudflare use Anycast. I have explained Anycast in detail in this attached video. So instead of giving different IPs to different regions, every POP called point of presence advertises the same IP address. Like Mumbai, Singapore, Tokyo, London, all are broadcasting the same IP address using BGP. Border Gateway Protocol. Now Rahul's packets sends packets to just one IP. The internet itself decides which POP is closest. Even better, suppose the Mumbai POP fails. It immediately stops advertising that route. BGP automatically reroutes Rahul to Singapore. No waiting for DNS caching, no waiting for TTLs to expire, no manual failover. This is why the Anycast failover, like Anycast provides faster failovers than DNS. But Anycast has one limitation. Here's where many engineers are gonna get confused. People think Anycast is replacing load balancer. It does not. It remember, Anycast works at layer 3. It only knows one thing. Which machine is closest? That's all. It cannot understand URLs, cookies, authentication, like HTTP request, all those things. Now suppose Rahul requests API orders. Should the request go to order service, user service, payment service? Anycast has absolutely no idea. Anycast with a reverse proxy running inside every POP. The request first reaches the nearest POP using Anycast, then the reverse proxy or the load balancer performs level 7 routing. We will cover reverse proxy maybe in another video. So, what is the complete architecture when you combine both types of load balancers? So, Rahul is in Delhi. He opens Amazon.com. DNS resolves the domain to the Cloudflare IP address. Now that particular IP address is broadcasted using Anycast routing by the Cloudflare. So Anycast routes Rahul to the nearest POP. Now reverse proxy processes that HTTP which reaches the global load balancer. Global load balancer decides the best region. They do some calculations or anything. Then it chooses do a regional load balancer at certain handoff, which is like healthy and is having a lower latency or something like that. Application processes the request. It connects the database if required. Responses come back. Everything this happens in milliseconds. Now suppose your interviewer asks, design a globally distributed e-commerce application. A good answer would look like this. At the edge, use Cloudflare or AWS Route S53 to route users to the nearest region. Inside every region, deploy a layer 7 regional load balancer like AWS and Nginx or HA proxy. Regional load balancer performs TLS termination, health checks, path routing, or for user sessions, avoid sticky sessions and all those things. Stores sessions inside a centralized Redis cluster, maybe. And this way, the entire request of Rahul will be completed in milliseconds. Now, easy trick to remember these layers here, which you will never forget. So, layer 3 asks which machine, layer 4 asks which service or port on that particular machine, layer 7 asks what is the user actually requesting. And if you remember these three questions, right, you will never confuse like these three types of load balance and the different layer we are having. So today we connected almost every concept we have learned so far, like global load balancer, regional load balancer, DNS, Anycast, BGP, right? And once you understand all these concepts, you will have the complete edge architecture, which is basically used by every companies like Amazon, Netflix, and all. And if you're enjoying the system design series, subscribe to Scalecraft and don't miss the next lesson because it's going to get interesting from here.